Quantitative random variables are split up into two categories, discrete and continuous. A continuous random variable is a random variable whose outcomes are contained in intervals. Continuous random variables have an infinite number of possible outcomes. A probability distribution is made up of all the possible values of a random variable and their probabilities. For every continuous random variable, there's a smooth curve called the density curve that describes its probability distribution. All density curves have an area of 1 underneath them. The probability of any individual value is 0, so we measure the probability that a given outcome will fall in an interval, which corresponds to the area under the curve. So the normal curve is a density curve that is bell-shaped and symmetric about the mean, with a normal distribution. The empirical rule states that 68% of the values fall within 1 standard deviation of the mean, 95% fall within 2 standard deviations of the mean, and 99.7% fall within 3 standard deviations of the mean. You can standardize a normal distribution by converting the data to z-scores using this equation. This new set of z-scores will produce a distribution with a mean of 0 and a standard deviation of 1. You may be asked to find the probability of an event, in which case you would want to know what proportion of terms are in a given interval under the normal curve. Problems like this can be solved using Table A or a calculator. Example, if the heights of all women are approximately normally distributed with a mean of 65 inches and a standard deviation of 3 inches, how tall must a woman be to be in the top 10% of all women in terms of height? This is a 5th percentile problem. You want to find what height corresponds to the 90th percentile. Look at Table A to find the nearest entry to 0.9 in the middle of the table. The closest entry is 0.8997, which corresponds to a z-score of 1.28. Using the equation for z-scores and plugging in the z-score mean and standard deviation, we can solve for x, the height that a woman needs to be in order to be the top 10% of women in terms of height. You can also use a calculator. Use inverse normal. You can find this height by plugging in an area of 0.9, a mean of 65, and a standard deviation of 3. Example 2. Considering the same situation in which the heights of all women are normally distributed with a mean of 65 inches and a standard deviation of 3, what is the probability that a woman is less than 63 inches tall? This is a probability problem. First, standardize the data using z equals statistic minus mean divided by standard deviation. Solving for z, you find that the standardized value of 63 inches is negative 0.67. Then use Table A to find the corresponding probability to a z-score of negative 0.67. On the left side of the table, find negative 0.6, and along the top, go to 0.07. The corresponding probability is 0.2514. So there is approximately a 25.14% chance of a woman being less than 63 inches tall. You can also use a calculator. Using normal CDF, you can find this probability by plugging in a lower value of negative infinity, an upper value of 63, a mean of 65, and a standard deviation of 3.